Okay, so this is lesson 60, part 2. And in this lesson, we are going to be talking about where we get this word captures from. We're going to talk about margin of error and what the width of your confidence interval says about your estimate. So we're focusing on where does the word captures come from, margin of error, and how margin of error relates to the width of your confidence interval. So this is just, this portion, this top portion is trying to enhance your understanding of a confidence interval. So what we have here is our sampling distribution of X bar. So let's just keep using our ACT example. We're going to keep using the ACT example from the previous page. What you see underneath here are confidence intervals. So this problem, or not problem, this question says, what does each line represent? Okay, well, let's look at this bottom one because it's the easiest one for me to highlight and write on. So this bottom one is a confidence interval. This is one confidence interval, and let's say it was our confidence interval. So this is 2505. The lower bound is 2295, and the upper bound is 2715. So let's say that this is our confidence interval. So each line represents a confidence interval. So the first question that I have is, how many confidence intervals are we looking at? Pause the video and actually count them up. How many confidence intervals are we looking at? Okay, so hopefully you counted up 25. There are 25 confidence intervals, which means that what is here is 25 samples. And for our specific ACT problem, this would be 25 samples of N equals 20 college freshmen taking calculus. So then, this question says, what does each dot represent? Well, if you look really closely, there's 3 dots happening. There's like a baby dot, then a big dot right in the middle, and then another baby dot. So we know, because I had us label this one, that the left side is the lower bound and the right side is the upper bound, and the middle dot is our point estimate. The middle dot is our point estimate. So in this case, it was our X bar. So your confidence interval is centered on or based on your sample value. What is the distance from the point to either endpoint? So what they're referring to is this point in the middle. So what they're asking for is, what is that? What is that distance? Well, we talked about this on the previous page. We know that that distance is the margin of error. We know that that distance is the margin of error. So we could get even more specific if we wanted to and say this is the lower bound, this is the point estimate, this is the upper bound, and now we know that this is the margin of error. This is plus the margin of error, and this is minus the margin of error. So just to recall our example, remember our point estimate was x bar equals 2505. Our upper bound was 2795 and our lower bound was 2295. The last question then is, how many of these confidence intervals capture the true value of the mean? They are trying to show you or remind you what the true value of the mean is. It is centered at the, it is the center of the sampling distribution. So that purple line now is true mu. How many of these 25 confidence intervals capture that true value? Well, 24 of them do. Notice you have a note here that says this is the interval, or this interval misses mu. This is the only one that does not capture mu. All of the other confidence intervals, this purple line is running through it somewhere. So that means that the confidence interval captured true mu. So 24 out of the 25, which equals 96%. Well, this now is our confidence level. "96% is our confidence level. 96% of our confidence intervals captured the true mean. So in our previous problem, we could be sure that 95%, let me say that a different way. We were 95% sure that this value was within 2 sigmas of the mean. And the reason why is because if you take a bunch of samples and calculate the confidence interval, about 95% of them would capture the true mean. So we're 95% confident that our interval captures the true mean. Yeah, I was going to mention something else, but I'm going to wait on that because you're already getting a lot of information in this lesson. So now we're going to talk a little bit about width. Now we're going to talk a little bit about the width of your confidence level. So the width of your confidence level is or depends on your margin of error. So depends on margin of error, which remember is made up of your critical value and your standard error. So the width of your confidence interval depends on how confident are you and what is the standard error of your sample. So I'm going to go even further to say that this standard error depends on n, your sample size. So standard error depends on your sample size. So what does critical value depend on then? Well, your critical value depends on your confidence level. Turns out that wider intervals make you more confident that your interval will capture the population parameter. So wider intervals make you more confident that you're going to capture the true value. So let me show you our table. Remember, these are our critical values right here. I want you to notice that as you get more confident, your critical value gets bigger. So a 90% confidence has a critical value of 1.645, but a 99% confidence gives you a critical value 2.576. Your confidence interval is getting wider because your critical value is getting bigger. So what this means is the wider your interval, the more confident you are that you'll capture the true mean, because your confidence interval increases, so your critical value increases. But you give up precision. You give up precision. And this Garfield comic is trying to illustrate to you or give you an idea of what we mean about precision. So he's watching the news, the weatherman's, and the weatherman's saying, taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. 40 below zero and 200 above. Okay, well, I want you to think about those temperatures. Do you know of a place where it gets 40 below? Or a place where it's 200 degrees Fahrenheit? Like, I feel like we would be on fire if it was 200 degrees Fahrenheit. So Garfield's response to that is, well, this guy's never wrong. Well, of course he's never wrong, because that's like, that range is all of the possible temperatures that could possibly exist. So, of course, he's not wrong, because whether it's 20 below or 101 degrees, which is really hot, it's in that interval. A precise interval would be something like, okay, tomorrow it's going to be between 40 degrees and 50 degrees. That's very precise. That's a 10-degree difference. This weatherman has a 240-degree difference. His range is 240. So the wider your interval is, the more sure you are you have the true mu, because it's wider. There's more chance that the true mu is in there, but you lose precision. And it works the other way as well. The more precise you are, the higher the chance that you're not going to capture the true mu. So it's like a double-edged sword. If you want to be really certain, you lose precision because it's really wide. And if you want to be precise, you are risking that you won't capture the true value. So that is the takeaway from this portion. Narrower intervals give a more precise range of plausible values, but you might not capture the population parameter. So more precise would be like 50 degrees Fahrenheit to 60 degrees Fahrenheit. But what if it was 61 degrees Fahrenheit the next day? Well, you missed it because your interval's so small. This big old ginormous interval, though, that would have been in that interval, because any temperature is going to be in that interval. So more confidence requires a wider interval, because as your confidence level increases, your critical value also increases. This funnel is a really good reminder, a really good visual of what we're talking about here. So notice the top, the widest part is 99% confident. And as we move down, the narrowest, the most narrow part is 90% confidence. So this is showing you that if you have a high confidence level, there is less risk. There is less risk of being incorrect, and it's less precise. So less risk of being incorrect, and this should probably say, but less precise. This bottom one is more risk of being incorrect, but it's more precise. So often you're balancing which one is more important. Is it more important to be certain, or is it more important to be precise? And that depends on what your job is, what you're investigating, what inferences you're trying to make. If it's a life or death situation, you're going to want to be more precise. So if it's a cost situation, it's probably better to be certain. Okay. So takeaways from this page. Where does this idea of capturing the true mean come from? It comes from here. This gives you a really good visual of your margin of error. Down here, we're talking about the width of your confidence interval. The wider your interval, the less precise you are, but the more confident you are. At this point, you can do the questions below, and when you're done, move on to part 3 of this lesson.